All right, so we're going to start looking at question 33 on page 165. So the map of a campground is shown below. Campsite C, first aid station F, and supply station S lie along a straight path. The path from the supply station to the tower T is perpendicular to the path from the supply station to the campsite. The path of FS, so the path between the supply station and the first aid, is 400 feet. The angle formed by path TF is 72 degrees. The angle formed by path TC and path CS is 55. We want to determine and state to the nearest foot the distance from the campsite to the tower. Okay, so this is ultimately what we want to find. Now, we need to take a couple steps to get there. Now, we're not going to be able to use SOHCAHTOA to automatically find this. The other day in class, I went over law of sines. So this is a question we're going to have to use a combination of SOHCAHTOA and law of sines. Okay, so our first step is to find the distance of F to T, and that one we're actually going to use SOHCAHTOA. Okay, so here's my person. So this is my adjacent. This is my hypotenuse. So my first step is to use cosine to find the length, find the distance between the first aid station and the tower. Okay. So I'm going to do cosine of 72 is equal to 400 over y. Now we're going to cross multiply, so y times the cosine of 72 is equal to 400 divided by the cosine of 72. So y is equal to 400 over cosine of 72. So this length is 1,294.427191. Okay, so now we want to find the okay, so now that we have this, so this is 1,294.427191. Now we can go ahead and find this length. Now, like I told you, we're going to use law of sines to do that. So law of sines, now based on the letters we're given here, I'm going to use sine of C over C is equal to the sine of F over F. Okay, so now let's take a look at this triangle right here. Okay, so we are given this angle and we just found this side, so I'm going to use 55 and the opposite side, which is this. Okay, so we're going to start off there. So sine of 55 over 0.427191. Now, since I want to find this side, I need to use this angle. Now, these two angles right here, the 72 and the one we need, are actually supplementary. So 180 minus 72 gives us 108. So the next thing I'm going to do is use sine of 108 over x. Okay. So now we're going to cross multiply. So x times the sine of 55 is equal to 1,294.427191 times the sine of 108. Now to solve for x, we're going to divide by the sine of 55, both sides. Okay, so x is equal to 1,294.27191 sine of 108 over the sine of 55. So now let's put all this into our calculators very, very carefully. So y equals, so 1,294.427191 sine of 108 over sine of 55. Okay, so x is equal to 1502.863142 nearest foot Okay, so 1,503 feet is our answer for this question. All right, so let's look at the next question. So let's look at question 34. All right, so Shay has recently begun kickboxing and purchased training equipment as modeled in the diagram below. The total weight of the bag, pole, and unfilled base is 270 pounds. The cylindrical base is 18 inches tall with a diameter of 20 inches. The dry sand used to fill the base weighs 95.46 pounds per cubic foot. To the nearest pound, determine and state the total weight of the training equipment if the base is filled to 85% of its capacity. Okay, so our start weight of this is 270 pounds. Okay, now there's a lot of information here, so I'm just gonna like map some stuff out and then we'll get into the question. Okay, so our start weight is this. Now what we need to find is the weight of the training equipment after the base has been filled 85% of its weight, 85% of the way, with sand that weighs 95.6 pounds per cubic foot. Okay, so we first need to find the volume of the base. So let's start with that for a second. Okay, now be very careful, because what do you notice? This is in inches, this is inches, and this is feet. So we need to convert these to in feet first. Okay, so 18 over 12 is 1.5 feet. 20 over 12 is a weird decimal, but we're just gonna leave it as that weird decimal, 5 over 4. No, that's not right. Five over 3. Okay. So the volume of a cylinder is pi r squared times the height. So pi radius is half of this. This is the diameter, so half of 5 over 3 is 5 over 6. So 5 over 6 squared times the height, which is 1.5. Okay, so the volume is 3.272492347 feet cubed. Now this is careful because this is the total. Now we're filling the sand up 85% of the way. So before we figure out the sand situation, let's figure out what the volume of it is, like 85% of the volume. So we're going to multiply our volume by 85.85. So the volume of 85% of the base is 2.781618,495. Okay. Now we need to figure out the weight of the base. Now we need to figure out the weight of the sand first before we find the total weight of what's going on in here. Okay, so the sand weighs this per pounds per cubic foot. So we're going to take this, so 2.781618,495 cubic feet. We're going to multiply that by 95.46 pounds over 1 cubic foot. Let's cancel those cancels. So now the weight of the sand is equal to 265.53333016. Now we want the total weight of the training equipment. So now the start weight was 270 pounds, so we need to add that 270 to what the weight of the sand that's going into the base. So now we're going to add 270 to this. So the total weight of the training equipment is equal to 535.53333016, and that rounds to the nearest pound, 536 pounds. Okay. All right, that was question 34. All right, so let's look at question 35. Okay, so given parallelogram ABCD, BF is perpendicular to AFD and DE is perpendicular to BEC. So we want to prove that this is a rectangle. Now, a rectangle is a parallelogram with at least one right angle. Okay, so our first step in proving this is a rectangle is we need to try to get BEDF a parallelogram first. Okay, so now let's take a look at what we're given and let's write down our statements and givens and our reasons and stuff like that. So we're given that ABCD is a parallelogram and DE is perpendicular to BEC. Okay. Now, how I like to go about this proof is to try to prove these two triangles congruent first, and then we can get the opposite sides, BE congruent to DF and BF congruent to DE. So we can say that this is a parallelogram. There's probably different ways that we can go about this. This is just one way that I'm going to go, how I'm going to do this, okay? So because this is a parallelogram, we know that the opposite sides are congruent. So let's say BA is congruent to CD. Now, we don't need this information right now, but while we're saying it, let's kind of, make our lives a little easier. So let's say both of the opposite pairs of sides are congruent. Okay, so in a parallelogram, opposite sides are congruent. Okay, so now we can say, so this side is congruent to this side, and BC is congruent to AD. Okay, so now let's look at some angles. We know that opposite angles in a parallelogram are congruent, so now I can say that angle A is congruent to angle C. So in a parallelogram, opposite angles are congruent. So now I'm going to say something about these right angles. So angle BFA, angle CED. Now I'm going to say this now so I don't have to say it later, and you're going to see why. I'm going to say that angle BFD is also a right angle. Actually, no, I'm not. We're going to say that till later, not to confuse ourselves. Okay. And these are right angles because perpendicular lines angles. Now angle BFA is congruent to angle CED because right angles are congruent. Okay, so now I can say that those two triangles are congruent. So now I can say triangle BFA is congruent to triangle DEC by angle side angle. Angle side, excuse me. Angle side. Angle side. All right, so now I need to try to get BE congruent to FD. Now I can do this by subtraction. I can take off CE and AF from these two sides, but first of all, I need to say that they're congruent, right? So I can say that CE is congruent to AF by CPCTC. Now I'm also going to say, while we're at it, BF is congruent to ED. Also by CPCTC. And I said, let's do the subtraction that I was talking about. So now I can do BC, because we already set it up here that it's congruent, minus CE is congruent to AD minus AF, or BE is congruent to FD by subtraction property. Okay. So now I have those two sides congruent, and I now have those two sides congruent. So now that I can say that BEDF is a parallelogram because both pairs of opposite sides are congruent. Now I need to say that there's a right angle. I started to somewhere up in here, but I didn't want to get lost and us forget about it. So now I'm going to say that angle BFD is a right angle because perpendicular lines form right angles. Okay, so now that I've said that, now I have everything I need to say that this is a rectangle. So now I can say that BEDF is a rectangle because if a parallelogram has at least one right angle, it is a rectangle. Okay? All right, and that is the proof.